So when we learn C programming language, and as we proceed to learn the advanced concepts of C programming, we surely miss dynamically growing data structures. Okay, so if we consider other programming languages that we use in our day-to-day life like C++, Java, or maybe Python as well, so these languages have, you could say, something called as a collections framework or that sort of a thing, which allows them to have a dynamically growing list of homogeneous elements. Okay, so this kind of list is not inherently present in a language like C. So there's a workaround, or you could say the way these things could be built in C. Okay, so that is something that we are going to see in this video today. Okay, so to begin with, to create a structure like a vector. Okay, so here in this structure we could see that we have created, so we have done a type definition so that we can use this vector as a data type itself. Okay, so here we have, first thing is the void pointer. Okay, so why we are using void pointer? So that we could use it with all kinds of database, all kinds of data, not database. So that is why we are using a void pointer here. So you can convert this pointer into any desirable data of that sort of a thing. Okay, so it will point to any kind of data. So that is the first key point. Secondly, we have size of each element. Okay, individual element. Okay, then we have the size, okay, of all the elements, or you could say the number of elements. And finally we have something called as capacity, that is the current capacity. Okay, so this whole thing is about the capacity and size. So there are two different things in this thing. So size is the allocated fields, okay, or you could say the stored fields, and capacity is the total available capacity, okay, or the allocated capacity. So you could have a capacity of 100 and you could be using the size of say 4 or 5, okay, and 95 or 94 extra fields would be available, or slots would be available. Okay, so now when we speak of dynamically growing structures, okay, so we need a mechanism for growing those structures. So in the beginning what we do is we do initialization. So you can skip this 12th line, okay, and directly moving on to the 15th line, which is the initialize. Okay, so vector initialization. So here we have created, or you could say, a function that takes the reference to the vector struct, you could say, and the element size, or you could say the size of the individual element. Like if we are storing integer in it, then we could pass the size of an integer. If we are storing some other data type apart from an integer, or you could say we are storing like any custom data type as well, or like custom struct that we have created, so that also could be passed to this thing, the size of that part. Okay, so inside this we have done the same thing. So we have assigned this size. So this struct elements only we are using, so properties we are using. So first is the element size that we have taken as a parameter. Initial size would be 0 because there is nothing on the list. Okay, and then we are defining a capacity, initial capacity. So here we have taken 4, but there is no such logic, or you could say predefined condition that you should take 4 only. So it depends upon you. So you could have it like 50, 100, whatever you want. Initial capacity is up to you. Okay, so we have set this capacity, and after that what we do is we have this void pointer, which is the exact list of that part. So here we'll do malloc, or you could say the memory allocation, and there what we'll do is we'll multiply our unit size with our capacity. So unit size is the size that you pass over here. So if you pass a size of an integer, which would be 4 bytes, so 4 bytes into, like if you pass the capacity of 4, then 4 into 4. Okay, so that's it. So after that we have taken a if condition. So if this is not allocated, if we get any error, so it will throw a empty error, malloc failed, and it will exit. Okay, so that is the initialization part. Okay, so after that, in the vector in C++ that we use, we have vector pushback. Okay, pushback function is there, which is usually used to insert the data into the vector. Okay, so to do that, what we do is first we check the capacity of the vector. Okay, if the size and capacity is equals, then what we do is, means the size is full, so we have almost filled in the complete capacity. So in that case, what we need to do is we need to twice the capacity. So now if your capacity was initially 4, okay, and when you have reached like 4th element also you have allocated, okay, then what we'll do is we'll multiply the capacity. See here, so if it was 4 initially, it will grow to 8. 4 2s are 8. Okay, and here previously, if you see here, we did malloc, okay, in this function on 19th line, you can say, and after that on 30th line we did something called as reallocation. Okay, so this is very important. So now we are resizing the structure. Okay, when we use array or that sort of a data structure, we have fixed size. Okay, so you cannot reallocate that part. So what we do usually when we use array is like we keep a redundant space. So like even if you need like 10-20 elements, you usually would go for like 100 elements, like, because if you don't know the exact capacity or the list how much you will require, so say you are reading from a what do you say, a CSV file, so you don't know how many number of points or the data that you might be reading. So in that case, something like this comes handy. Okay, so this is how we allocate this thing. So in realloc, okay, what we do is first we take the location where we want to reallocate, or the pointer to the data, okay, in this case where the reallocation needs to take place. So this data that we have passed here, then the capacity, which is the newer capacity, okay, into the size, existing size. Okay, so that size we multiply. So now we have a new data over here, so this returns a pointer. Okay, so previous data will be there, just that you have a new pointer over here. So first we check if there's any error or not, in this case to the new void pointer that is returned. If there is no error, okay, then you proceed to assign that new data, okay, this pointer to the pointer over here. Okay, so this is an important step in realloc, because you get a new pointer. So like this exact space wouldn't grow itself, so you get a new pointer, and that pointer you need to assign to the previous pointer in this vector struct. Okay, so that is one step. And if in case you get any error, so like there are multiple reasons why this could fail. Okay, so you might be running it in a VM or something, so in that case also sometimes things fail. Okay, so other time if reallocation fail, it is usually like you have like crossed some limits of your heap or that sort of a thing, then in that case also it fails. Okay, so very highly unlikely it might fail, unless you are like messing up the pointer manipulation thing. Okay, in that case also it could fail. So just in case if it fails, then you show that error and then you free the vector. Okay, so after malloc you need to call free as well. Even if the thing fails, you need to free that memory. Okay, and once here we have that thing, so copy the element into the array, that will do. Okay, so here what we have done is the vector data plus the newer size of this thing. Okay, so now we have that thing. So what we do is we do something called a mem copy. So this mem copy thing takes 3 parameters. Okay, source, destination, and source address, destination address, and the offset. Okay, so in this case our target is the destination, this is the source. Okay, from element it will take, and here it will be the size. So that way it will copy in this case. Okay, so individually it will copy everything, and here we see the size is also incremented, like all the elements it will be encompassing or that sort of a thing. Okay, so size will be incremented, like next element you want to add, right? So size, so one more element is added in that, for that you have a size. Okay, irrespective of this operation, size will always be incremented as you add new element in it. So vector get method is also there. So for this method what we do is to check whether we have elements in it or not. So here whenever we search from vector, we usually use a get method which is based on index of the element. Okay, so here as it is a dynamically stored thing, so we have a index value, so that we check whether the index value that is requested is within the bounds or not. So that is the first thing that we check over here. If this vector size or the existing number of elements present within the vector is less than the index that is requested by the client, or you could say the user, then we'll throw error, that is index out of bounds error. Okay, after that, if the element was literally present, so here we have exited this thing, and if the element did exist, then what we do is we return a char pointer from here. Okay, and vector data plus this will be the initial pointer to that data plus the offset. Okay, so he has asked for a index, he has like index he has given 4, so 4 into like the unit size was like 4 bytes, so 4 4s are whatever the value will be, it will offset over there. So this address, starting address plus this extra added offset, so it will jump to that address and it will return that value through this. Okay, and after that the final method that we have here is vector free, so all the allocations that we had, that will free from this. So here first thing we'll do is we'll free the pointer which is pointing to all the data over here. After that, once we free that data, we'll assign a null pointer to it or null value to it. Okay, so after that we set the size to 0 again, capacity to 0, and element size to 0. Okay, and now that we have created this whole structure, okay, after that we have used that part into our main. So for that we have come into the main function. Here we have defined the vector. Okay, and we have called the vector initialization method called vector init. We have passed the reference of this vector, and like I said, we have passed the size of the individual element. Okay, like the unit elements. So if I pass a size of float over here, then my list would be a list of floats. Okay, so that's the part. And if I'm using here, I'm using integers, so I'm using an integer list. After that, I'm pushing some elements into this thing. So here what I'm doing is I'm pushing the elements 1 to 10 0 to 10 into the list. Okay, one by one I am pushing. So here what I'm doing is I am giving them the address itself of the vector as well as this variables, and once that is done, I am calling the vector get method as well in another for loop. Okay, in this for loop I am getting that value, okay, that pointer value into my integer pointer over here. So because I use an integer over here, so it is expected of me that I will be using an integer over here as well. Okay, so if you use some other data type here, then you might get some garbage value or a wrong interpretation of that value. Okay, so in case of this thing, if you use a float, then you might get a wrong interpretation of that value. Okay, so just make sure that whatever data type you are passing over here, you are supposed to use that data type along with the pointer over here. And once that is done, we simply print the value. Okay, and after we are done with all our operations, we can simply free the vector that we have allocated. Okay, and after that we could return 0 with it. Okay, and this was the part. So now if you want to experiment with the same thing or the concept that we have applied over here, so what you could do is, as an experiment, in this code itself I have defined this thing that I asked you to skip in the beginning of this video. So this structure, the person structure, okay, so as an exercise you could try creating this thing. So create a vector of structures of vector of a person, this thing, person struct in this thing, and add elements to it. So that should also work with this code. Okay, so this code is designed in such a way that it should support this operation as well. So as an exercise you could do that part as well. Hopefully this was helpful for you guys. Okay, thank you.